national presentation. So super excited to be able to share with you. This is actually also my first time presenting in Sydney. So super excited about it. So a little bit about me. I'm a software engineer from Buenos Aires, Argentina. I've been working with Django since 2011. That's quite a bit of time ago. I just looked it up and it's version 1.3. Who has been working with Django? Has anyone been working with Django since 1.3? Wow, we have a couple of veterans here. Lots of war scars. I'm also an accidental indie hacker. It's not something that I plan to get into, but it sort of happened. So if anyone wants to learn more about it, we can chat about it later. The title of this talk is Cloud Native Django. So first, I would like to define what I mean by cloud native, and it's usually seen as a sort of marketing buzzword for companies trying to charge you more for some things. But actually, there are some pretty cool things about cloud native that are worth exploring a little bit more. So cloud native is a set of patterns and a set of tools for building and operating scalable applications in the cloud. They enable loosely coupled systems that are resilient, that are manageable, and that are observable. I want to focus on that third point. I think all of them have a lot in common, but there's something very interesting about observability here. So there's also a very strong focus on automation to enable engineers and teams to make very high impact changes frequently and safely. That's what DevOps is about, and Cloud Native emerges very well with that mindset. So there's this Cloud Native Computing Foundation that sort of develops or serves as a host for this set of patterns and tools. And I want to talk about two of the highest growing projects from the Cloud Native Computing Foundation and how they apply to your Django projects. Okay, so let's talk about observability. And whenever I ask people about observability, they usually mention two things. So observability is about the three pillars. Has anyone heard about that? So it's logging, traces, and metrics, and how you push that to your systems, your dashboards. It's also about dashboards, how you use dashboards to monitor, that's the key word here, the health of your system. I want to challenge those two notions. I want to challenge the idea that observability is about the three pillars and that observability is about dashboards or monitoring. So to make that leap, I want to move away from thinking of observability as monitoring tools and as about the telemetry data, and more about what are the capabilities that we want in our system. What do we want to get out of our investment in observability? So a couple of questions to think about the capabilities that we would want. These are taken from the excellent book Observability Engineering. So for example, can you identify the user that generates the most load in your system? How about the third one? Can you understand what any particular user may be experiencing at any point in time? Can you compare arbitrary groups of user requests to correctly identify the attributes shared by those users that are experiencing unexpected behavior? If users complain about timeouts, but your 99, 99.9, 99.99 percentiles are good, are you able to find where those timeouts are happening? What all of these questions have in common, or inquiries, is that they are not solved by traditional dashboards, because they are about the unknown unknowns. Dashboards work with the things that you already know may fail, so you're actually building your dashboard with a time series chart or a metric to monitor for known things. Observability is about much more than that. It's about understanding the state of your system. So a couple of common misconceptions. Observability is not monitoring. Monitoring relies on previous knowledge of might go wrong. Observability promotes active exploration. It promotes curiosity. You should be able to use external tools to question your system, make chart against multiple dimensions, and find and if you have any problem, be able to zero in on what are the characteristics under which this problem is happening. So observability is also not about telemetry. Telemetry is the data that you collect about your system and that is sent to your monitoring and observability tools. I'm sure a lot of you have worked on systems that had very good telemetry. You are collecting a lot in your logs, in your metrics, in your traces. But then when you're actually looking at your logs without the proper tooling or without the proper infrastructure, you're just like trying to make sense and correlating logs across different services and squinting at the time sums, trying to match what is going on across different systems. You can have really good telemetry and yet not have the kind of observability that I'm talking about. So to go back to first principles, observability is a term that comes from a mathematic and control engineering branch called control theory. The term was coined by Rudolf Kalman. That's the famous inventor of the Kalman filters, if anyone has heard or used them. And he describes it as a measure of how well internal states of a system can be inferred just from knowledge of its external outputs. Now, these might be a little abstract at the moment. Please bear in me. I'll explain how that applies to our software systems. So to have an observable system, you must be able to understand the inner workings and any state it may have gotten itself into, even new states you have never seen before. You cannot do that with traditional monitoring tools. You must also be able to understand the state solely by observing and interrogating with external tools. It would be awesome to hook up a debugger and sort of understand what's going on in memory in our production code, but most of the time we're not able to do that. Sometimes we aren't even allowed to pop open a shell in our production code. So we must be able to understand whatever state the system is in just by looking at this output that is generated and interrogating it with specialized external tools. We must also be able to understand that internal state without having to ship any new custom code. Of course, you must be thinking about observability when you develop a feature so that it helps you and it aids if something happens later. But you shouldn't be able to, or you shouldn't need to add custom code, the kinds of specialized log statements that are just there to debug something that appeared in production. You should be able to do that with existing observability instrumentation. So why all of these matters now? We're moving from monoliths to distributed microservices architectures. Our systems get more complex. We are moving from single databases to polyglot persistence. We're moving from manually configured servers that you can just jump into an SSH and open HTOP or whatever in a single server to dynamic elastic infrastructure where servers may pop in and out at any moment depending on demand. And businesses demand a faster rate of change. So we are introducing more and more changes more frequently with a shift on left on quality and security. That means that developers more and more have to pay attention to how to maintain that level of quality with a faster rate of change. So we need these improved tools to understand what is going on in our production systems. The current monitoring tools do not help us with that. And we have to do this with higher and higher demands on reliability and availability of our systems. We cannot take our systems down for maintenance for several hours like we used to do. So I talked about why monitoring tools and dashboards are not observability or are not all there is to observability. I would also like to challenge the other notion that there is these three pillars, metrics, tracing, and logging. And I would like to propose that all you need really is something called wide events. And I'll explain what that means in a bit. So let's start with logging. So I'm pretty sure if you do some kind of logging, you have moved on a few years ago from free-form text logs to some kind of structured logging, either JSON or key value-based logging. And that is great. I mean, they're much more understandable and searchable than traditional free-form texts. If you're doing that, you might also have found useful to add a sort of correlation ID, so you can understand like every log that is part of the same transaction. You probably also added some start and end times, and if you have a start and end time, then you have what's called a span, something that occurs. You can log or generate an event for an activity that occurs over a span of time. If you put that all together and you add arbitrary attributes, then you have what is known as a wide event. Wide events have an arbitrary number of dimensions. You can put whatever attributes that you want. And then you can also put your metrics into wide events. That's a metric is just an event with an attribute that remains constant over some time and whose value may change. And you can use your tool to graph your metrics, and you can use your tools to group those metrics by another dimension and do all sorts of analysis on that data. So OpenTelemetry is built on this notion of a wide event. It still has these sort of separated signals, but on the back end, it's just sending wide events to whatever system you configure it. And the thing about wide events is that they enable you to do a visualization just as this one. This is Jagger, which is a tool to view distributed traces. And if you have all those parts in your wide events or your structured logs, then this really gives you a very good view about what is going on with a single request, and it's sort of the workhorse of your observability analysis and discovery. Perfect, thank you. Okay, so OpenTelemetry is an open API that serves as a sort of focal point for working on different instrumentations. So the idea is that by producing a standard API, you don't have to if you want to use sorry. So OpenTelemetry is an open API for producing telemetry and observability data. By focusing engineering efforts on this standard API, we can produce great support for every language. We can produce great support for the most common libraries on every language. What happened before OpenTelemetry is that every vendor had varying degrees of support. It usually favored the bigger vendors with the most capital, like some companies over there, Doggy Company, which charge a lot of money because they have all this support. So OpenTelemetry levels the playing field by providing this common API. So you configure and you instrument your app for OpenTelemetry, and then you configure where you're going to export the data, and that gives you much more vendor neutrality. So how do you instrument your Django app? First, you decide on whether you want what is called manual or automatic instrumentation. I'm going to show how to do the manual instrumentation because I think it's actually pretty simple and it's actually much more flexible than doing automatic instrumentation. Just know that there are two ways that you can instrument your app, and it's not hard to go on the manual one. You also need to configure whatever instrumentation libraries you're going to add. So, for example, in many Django projects, you're probably also using maybe CyclePG for making requests to your database, or maybe you're using Redis, and you probably want a span or a trace for each database call, for each cache call, or when you're calling to external services. So you're going to configure those instrumentation libraries. Then you configure your processors and exporters to push the data to either a vendor or an open source solution, and you're good to go. So a manual instrumentation of a Django project looks pretty much like this. You have to take care a little bit if you're using a server like Unicorn. You have to reattach some of the stuff shown here. But I'm just showing this to, so you know it's not hard at all. It's just a couple of lines. Here I'm configuring what's called a tracer provider, which is going to be the implementation that we're going to use then in our app to generate traces. And I'm configuring this OTLP span exporter that's going to use the OpenTelemetry protocol to push those events to a vendor that I have configured via environment variables. I just set up that processor and that exporter on my provider, and then I instrument with each library that is useful for me. How do I use it for the libraries that I have configured? I don't have to do anything else. I'm going to get like request traces for Django. I'm going to get a trace for every database call that I make. If I want to add like a custom span, maybe I have like a domain layer and I want to monitor every time I call certain services within that domain layer. It's super easy. I just obtain a tracer in my code and call this start as current span, which is going to start a nested span under the current transaction. I give it a name that makes sense for my project. And then I can also configure later the attributes of my span. I can also mark a certain span as having had an error. So I can pass an exception, and then it's going to log that span ended up with an error. So it's super simple to use OpenTelemetry. And I want to talk about feature flags now, because I think they are two things that merge really well for controlling changes and then getting observability on those changes that you are doing in production. So feature flags are usually, if you haven't used them yet in production, they may appear simple at first sight. So they may seem like it's just a remote evaluated if statement or Boolean, but they are actually quite a bit more. They hide quite a bit more complexity behind that. So for those who are not familiar with feature flags, they are a technique for modifying system behavior without changing the code. So they work by performing an evaluation for a given flag key, that's probably a string, with an evaluation context. The evaluation context usually contains data about the current user or the session. So you can say like you can use that to select a certain subset of your users and use that for targeting. So as a very minimal code example of how a feature works in code, you create a context, for example, with user ID and email, and then you call this feature flag function. You pass in the string that you're going to use as a key. Usually, in most APIs, you need to pass a default value because we're usually talking to a remote service here. So if anything fails, we want to have a default value we can fall back on, so that a vendor or another service being downed doesn't take down our app with it. And we need to pass a context that will be used for evaluation. Feature flags can be used for release scanning or progressive rollouts. That is when you have a new feature, you're not yet sure how it's going to perform in production, either in business terms or in technical performance terms. So you just push it to just a very small subset or percentage of users, and you progressively increase that percentage. You can use feature flags for A/B testing, experimentation, trying out different things in production. Some people use feature flags for permission toggles. So you can use a feature flag for your premium or paid users, or usually what happens and what I've done in my business is some business user is requesting or a premium user is requesting a certain functionality. So I push some first version of that functionality, and I enable it just for them as beta testers, so I can try how that functionality works for them before general availability, and I can progressively roll it out to more and more users. Another interesting use case for feature flags is operation kill switches. So these, for example, if you have, let's say, an e-commerce site that shows recommendations in its homepage, and those recommendations have a high load in your system, if at any point you're experiencing a very high level of load for whatever reason, you might use that to manually disable that feature so you can get a little bit more air in your system, and you can handle unexpected loads. So feature flags have quite a lot of use cases, and there is a lot of complexity hiding behind that. Just think about what are the permissions that are required for toggling a feature flag on or off, having audit trails, having dashboards for monitoring how a feature flag is performing in production, how our experiments are going. So it makes sense to do for feature flags what OpenTelemetry did for observability. And that's what OpenFeature does, is one of the newer cloud-native projects, and it's growing super fast. OpenFeature is an open standard for feature flag management, created to support a robust feature flag ecosystem. So before OpenFeature, every vendor, every provider had to implement their own libraries or their own SDKs for every language, every framework, and that really left you with little choice if you wanted like high quality libraries and SDKs across many different languages. So we can transform this problem into one where through OpenFeature, every vendor just has to implement a provider that plugs in on the back of the OpenFeature SDK, and they just have to implement a very small API surface, and then we can focus our efforts in providing great support for different languages and different frameworks. So OpenFeature can be configured very easily. Here I'm configuring both OpenFeature with a provider, could be whatever provider, launched darkly or whatever you're using. Here I'm also adding what's called a hook, and I'm configuring the OpenTelemetry hook, and that's going to push an event every time a feature is evaluated with the result of that evaluation. So I get in my traces, if I zoom in on a request, I can know exactly what feature was evaluated, what feature flag, and the value of that, and that can be super useful for debugging. To use OpenFeature, you import its API, you grab a client, you create this evaluation context, which takes a targeting key as a first argument, and then a dictionary of different attributes you may want to target on. And then you can use that client to evaluate. Either you can evaluate either a Boolean value or a string or an object. There are lots of variety here. Okay, so what's better than just that? Having very good integration with Django. So this is a project I built recently. I would like for you to try it out and let me know what you think about it. This is integration for OpenFeature with Django. Of course, you can use OpenFeature without it, and you're very welcome to do so. But this to me shows what's possible with something like OpenFeature. Django OpenFeature works with every feature provider out of the box. I don't have to add like a specific integration with that because it uses OpenFeature, and then you can configure whatever provider you want. It has support for Django debug toolbars, so you have like you can open one of the debug toolbar panels and see what features were evaluated for processing that request and what's the evaluation context that was used to resolve those feature flags. You get custom template tags, so you can resolve feature flags directly in your templates. You also have a configurable mapper from request to evaluation context, so you don't have to pass manually the evaluation context every time. And there are also some testing utilities that I've been working on. So one of the things that you might want to do when you're using feature flags is test your code with different values of the feature flag. So in this case, with Django OpenFeature, you configure a test provider, and then you can use this context, so this decorator or context manager to override the value of a feature for a certain test case, and you can also use it as a context manager, and it works nested. So can really test that every version of a feature works for you. So wrapping up, OpenTelemetry is a great foundation for building systems of observability. It has excellent support for instrumenting common libraries. OpenFeature does for feature flags what OpenTelemetry did for observability. With feature flags, you can have a high degree of control of how and when your changes impact production. With improved feature management and observability, you can perform this feedback loop fast. You can go fast to production without having to sacrifice quality or resiliency. That's what DevOps is all about. So thank you for listening. Hopefully it wasn't too much. Happy to answer questions.
Yeah, and I love the fact that it's an abstraction behind like third-party vendors, because usually, like, you know, you just get stuck with one vendor. That's good. It's like power to the people.
Yeah, they're actually, we're working. I've been involved with the OpenFeature project almost as a maintainer of the Django SDK, and there's actually some specification effort on what is called the multi-provider or composite provider, which would let you do things like, for example, evaluating multiple providers and comparing and generating alerts when they don't match. So you can use that to migrate a system from one provider to the other. You configure both, and as long as they stay the same, you can perform the switch over to the new one. You can also configure different providers for different parts of your system if you're migrating in steps, and that's something that OpenFeature also supports with a feature called domains. So you can get clients for a specific domains, and those domains are on the back connected to different providers. So it's pretty flexible framework.
Nice. Do we have any questions? Just raise your hand.
Yes.
Oh, I'm interested how the wide events you mentioned at the beginning, how they fit in with the OpenTelemetry libraries.
So at the back, like OpenTelemetry is pushing wide events. Sometimes they're called, they may be called stands, they may be called metrics, or they may be called events. That would be what maps through logs. But at the end of the day, they're just, they let you add an arbitrary number of attributes, and they all have the same shape.
Yeah, I was interested if you could be pushing logs and also have them eventuate in something like Jaeger to do.
Yeah,
tracing.
you can push logs through OpenTelemetry. Some people are doing just that. Yeah. The key thing is about the wide event is that what you have on the other side as a storage solution or the vendor that needs to support these kinds of events. The key thing about the wide event is that the attributes are not like predefined before. So usually with some vendors, you have to pay for each different like dimension that you want to store. If you're using wide events, usually your vendor should be able to support like this arbitrary number and don't charge you more for it. I'm using Honeycomb as my OpenTelemetry solution for analyzing and processing my telemetry data, and you can do just that. You can push whatever attributes that you want, and then perform like aggregation, grouping, and stuff like that, filtering on an arbitrary number of dimensions. And that's what you really want when you want to debug a problem in production. So observability is not going to give you it's not going to provide a solution. It's not debugging, but it will, if done correctly, it will pinpoint exactly where the problem is. And then you can look into the code and understand what the fix needs to do.
More questions? No one?
Well, thank you so much.
Oh, one more from me.
Yeah.
So maybe on the high level, what I want to understand is like how, so what happens, so you integrated this, so you use this code to instrument your libraries, collect the events. On the very high level, can you explain that? What happens next? How those events gets actually collected and pushed to the receiver, event receiver?
So the high-level idea of an instrumentation library, and then I go to your question, is it's just in Python, it just monkey patches the main entry points of that library to insert the instrumentation code, which is opening and closing spans and providing the right attributes.
Right.
That gets sent to the processor that usually you're gonna batch those events in the background using a background thread, and that is like, it works with the OpenTelemetry SDK. And once you have collected enough number of events, those get flushed, and they are flushed. What you usually do is you use the OpenTelemetry protocol, OTLP, and most of the vendors have some endpoint where you can push OTLP events.
Okay.
I think they have OTLP JSON, and there is some OTLP with protocol buffers or stuff like that.
Okay.
But there's a wire protocol for sending events to a vendor or an open source solution, and then they transform that to their own storage system. Is that
Cool.
what you're?
Yeah, no, that makes sense. That's a very good explanation.
OpenFeature is also working on a sort of wire protocol. They call it the remote evaluation protocol, because the thing that you have right now with OpenFeature is that you still need to create a provider for every language. So you don't have to create like an SDK for every framework, but you need a provider to talk to your API, because every API from every vendor is different. So they're actually working on standardizing like a minimal remote evaluation protocol, so that a provider can just implement that, and you can use the standard like off-rep OpenFeature remote evaluation protocol provider, and then you have support in every language from day one.
Right.
If you want to use advanced features, you might want to use the custom provider, but you can just use a standard provider, and that's going to work with every vendor. So that's pretty cool too.
Yeah, that's very cool. I'll tell you later what we use for feature flags. that's not even close to this. But anyways, cool. Yep.
So OpenTelemetry has Jaeger. Yeah, OpenTelemetry has Jaeger as the open source solution to surface the events. Is there an equivalent in OpenFeature?
Yeah, OpenFeature has FlagD, which is minimalistic, but quite, full-featured for many use cases. Flags like management solution. It's written in Go, and it's like super simple, super fast, and you can use that. You can also use like Go feature flag, and there are a couple of open source solutions that you can run on your own infrastructure, and they have providers for most languages.